So alcohols we did they've got OH, high melting and boiling points, very soluble in water, and we did primary, secondary, and tertiary alcohols. Primary has one carbon chain, secondary has two carbon chains, while tertiary has three carbon chains. I said then formation of alcohols, there are a number of ways where alcohols can be formed. So formation. As a formation of alcohols. So we did a couple of reactions already. So I'll just write down the names of those reactions. One was hydration of alkenes. You can convert an alkene into an alcohol. Okay, so number one, hydration of alkenes. And so if you have an alkene, so H and OH will get added to it. So you can add water to it in the form of steam. And that alkene, the double bond will turn into single bonds, and water molecules are going to get added to it. So एक जगह पे there's going to be H and OH attached to it. So OH and H are going to get attached to it. Hydration of alkenes, and the conditions for hydration of alkenes is that you need 300 degrees centigrade temperature, 60 atmosphere pressure, and you would need an acid catalyst. It's most likely going to be phosphoric acid. That's going to be your catalyst. फिर और क्या था? We did another reaction in which there's actually a dehydration of alkenes as well, which is kind of very, very similar. We'll do that as well. Okay, now dehydration of alkenes is the exact opposite. So it's the exact. This one is the exact opposite of hydration of alkenes. इसमें बस वो होता है कि if I have let's say I have a butanol molecule and alcohol, and it's got all these H atoms. Okay, that's your carbon chain. Now what will happen is the OH is going to be lost, and the H is going to be lost as well. Okay, OH is lost, and the H could be lost from the right, or it could be lost from the left. So remember this whenever alkenes are getting formed, especially through dehydration, a number of products are possible. So a number of products are possible in this case. Okay, that's another one. So OH तो खैर lose हो गई होगा. The H can be lost from here, or the OH and H can be lost from this side, and you'll end up with a double bond in between. Okay, so you'll get two different alkenes. So it's either going to be this or it's going to be that one. या फिर ये वाला. Okay, so two different products are probably going to be possible. The conditions that are required for this is you can either use concentrated sulfuric acid, which is your dehydrating agent, or you could use you could heat with Al2O3 or SiO2. Okay, that's also known as pumice or zeolite. Okay, so that's those are the conditions for this reaction. So you can dehydrate this alkene, and it will form the alcohol back again. It will form the alcohol can form the alkene back again. Now the other thing is second reaction of formation of alcohols. That's we did that. That's the SN reaction, nucleophilic substitution. We already did this. Of halogenoalkanes. The nucleophilic substitution of halogenoalkanes. What happens in this reaction is, okay, when you have nucleophilic substitution, what happens in this reaction is your whatever the halogen is, it's going to get substituted by OH. Okay, we did the entire mechanism in the previous topic of halogenoalkanes. You need NaOH aqueous and reflux. And it will turn back into an, sorry, the OH is going to get substituted. The Cl is going to get substituted by an OH. अच्छा फिलहाल ये दो काफी और इसमें लिख देता हूँ कि C halogenoalkanes इस वाले में C alkenes अच्छा anyways moving on. So what do we know about alcohols? First thing is there's a very small thing about alcohols, and that is they happen to be terrible acids. So alcohols are extremely weak acids. Which kind of means that they're not acidic at all. Okay, extremely weak acids means the ionization is even less than water, which means that they're not really going to produce any H+1 ions. So ionization is even weaker than when compared to water. Okay, compared to water, its ionization is even lesser. इधर मैं लिख भी देता हूँ कि they're not actually acids, ठीक है? So they'll ionize very, very little. So if you see an alcohol, and it's got an OH group, there's going to be a reversible reaction that will happen or can happen, in which the OH can be broken down. It can ionize, and it if it ionizes, it will become O-1, and it will become H+1. Now very few H+1 ions, like almost non-existent. Okay, so extremely weak ionization. So it doesn't like to lose H+1 ions. And there's a reason for that. And you don't have to know the reason right now at the moment, but the reason is that it all depends on the negative charge over here. In the case of alcohols, what happens is that they've got a carbon chain, and the carbon chain has an electron donating effect, which is why this negative charge becomes very large. And which is why the H+1 is very strongly attracted to it. So that means the OH bond becomes it kind of becomes very strong. And it becomes harder to break that the OH bond. So ये उसकी reason है कि the carbon chain has an electron donating effect, and the negative charge on the oxygen becomes bigger in size. And if it's becoming bigger in size, it will attract the H+1 more. So hardly any ionization. Is that clear?
Yes.
Yes.
अच्छा इसका करना क्या है कि so they're terrible acids. So no reactions. ठीक है, they don't not acids, and they're not going to have any acid reactions except for one. बल्कि आप कह लो कि no acid reactions. So no acid-base reactions. But alcohols, they do react with metals, but very slowly. And they only react with group 1 reactive metals. But very slowly. Normally group 1 metals have very fast reactions, but not with alcohols. Like if you have an alcohol and you've got an OH and you react it with sodium, what will happen is that sodium is going to lose its electrons and the H+1 will gain electrons. So CH3, CH2, O-1, the H+1 will gain electrons to form H2 gas. Or यहाँ पे there's going to be Na+1. That will join, with this oxygen over here. So it is kind of an acid reaction. A typical acid reaction, it's a redox reaction. And it loses electrons. And your H+1, which ionizes, ends up gaining electrons. So it gains electrons. And you do have a reaction, but it's very slow. So slight effervescence is seen. So very slight effervescence is going to be seen. So alcohols are extremely weak acids, one thing. And now moving on to the other thing. I should remember this, whenever you have an alcohol examples, any alcohol. So let's say you've got a cyclic compound and it's got so you've got a cyclic compound, it's got this stuff. and it reacted with Na. Two sodiums will be required, and the product of this reaction is going to be that the molecule, ठीक है, उसके जो OH है ना, H, they will all turn into H2. And H2 gas is going to be produced in this reaction. ठीक है, clear है?
जी सर. Yes, sir.
अच्छा, अब ये कि तो ये तो उसका खत्म हो गया उसका. अगला पार्ट है. Now this part is important, that alcohols, oxidation of alcohols. So remember, there were actually three types of alcohols. You had your primary alcohols, secondary alcohols, and tertiary alcohols. So primary alcohols will get oxidized. So they'll get oxidized, and they will form aldehydes. Now your aldehydes will get further oxidized, and they'll form carboxylic acids. So this is the scenario situation that aldehydes will turn into carboxylic acids. Carboxylic acids will further turn in, they're not going to get oxidized. So this is your oxidation chart. What's a primary alcohol? That it's got just one carbon chain that's attached to it. And on two sides, they're going to be hydrogen atoms. Plus, there's going to be an OH also. Now, this primary alcohol will turn into an aldehyde. So that particular carbon atom will turn into double bond O, and it will turn into H. And then what will happen is that particular carbon atom will then get further oxidized, and another oxygen will get added, and it will turn into a carboxylic acid. ठीक है, तो ये सब कुछ, अच्छा ये सब कुछ हो रहा है. Primary alcohol turning into this thing, and then further getting oxidized. ठीक है, so that's your reaction. Now the conditions required for this reaction is, and remember, everything will happen to that particular carbon atom. That was the alcohol. So everything is happening to it. The same carbon atom then turns into carboxylic acid. The conditions that are required for this reaction, you need an oxidizing agent. The oxidizing agent for the first step is number one. Number one is you can use acidified KMNO4. Number one नहीं है. Number one is you can use K2Cr2O7, potassium dichromate 6. and that's got to be acidified. And you're going to heat it with reflux. You're going to heat it with reflux. And when you react it with potassium dichromate 6, there's going to be a color change, which is going to be orange to green. And the second one is that you can react it. So the second one is you can react it with KMNO4 and potassium manganate 7, which is going to be acidified as well. And you're going to heat with reflux as well. So you're going to heat with reflux, and the color change in this case is going to be purple to colorless. It's going to be purple to colorless. And that's it. Those are your two oxidizing agents. It's either the first one or the second one. अच्छा तो वही चीज यहाँ पे होगी. अच्छा वही चीज यहाँ पे होगी. But there are going to be two further oxidizing agents. One of them, so there are going to be two further oxidizing agents that can oxidize an aldehyde to a carboxylic acid, and those two further oxidizing agents, they are number 3 जो है ना, that is known as a यहाँ पे कर दिए as a number 3. अच्छा there's a thing called a tolerance reagent. Now what's a tolerance reagent? It's silver with NH3 twice. It's a complex ion and it's got a +1 charge. ठीक है तो ये पूरी चीज है. So it's basically formed when you mix aqueous ammonia. मतलब इसको form करना तो just mix aqueous ammonia with aqueous silver nitrate. अच्छा plus aqueous silver nitrate. अच्छा that's tolerance reagent, and when you mix it with tolerance reagent, there's going to be a silver mirror that's going to be formed. That's your observation. Silver mirror का मतलब है कि ऊपर जो layer होगी ना, it's going to form silver at the top. So that's going to become silverish. And so silver mirror is formed, and there's going to be a black precipitate that will also form. And similarly, ये तो tolerance जो है वो उसका जो silver mirror है ना, ठीक है, that kind of looks like this. कि वो silver produce होना शुरू होता है. The silver gets reduced, that's why. ठीक है, it becomes very silverish. ठीक है, there's a layer of silver that gets formed when this happens, and inside there's a black precipitate that also gets formed. So silver mirror वो लिख देता हूँ, reason क्या है? Because it's an oxidizing agent, itself gets reduced. So silver ions basically end up getting reduced, and they end up forming silver. अच्छा फिर इसी तरह you've got the number 4, which is what's number 4? Okay, number 4 is there's a filling reagent as well, filling solution. It's basically a blue solution that contains copper 2 plus ions, which eventually get reduced to a brick red precipitate of copper 1 oxide. TK, it eventually gets reduced to a brick red precipitate of copper 1 oxide, and in this case, you would have to heat as well. So oxidizing agent itself gets reduced. So those are all your oxidizing agents. ठीक है, potassium dichromate 6, KMnO4, and so on. ठीक है, उनको underline भी कर लेते हैं कि that's all of them. KMnO4. And you've got filling. ठीक है, those are all your reagents. ठीक है, we'll come back to this later. ठीक है, that's oxidation of aldehydes. Another thing is that if you want to stop at an aldehyde, how can you stop the reaction from moving further? So the question is that if we want to stop at an aldehyde, how can the reaction be stopped?
Stop heating. सर यानी हीट करना बंद कर देंगे ना?
उसमें ये कि एल्डिहाइड को बीच में से ना जैसे ही बनेगा ना उसको निकाल दो बाहर, लेकिन उसको निकालोगे किस तरह? If stopping the reaction at aldehyde, ठीक है, so basic idea is remove the aldehyde, ठीक है, separate it from the mixture. Like, how would you do that? So what you're going to do is use distillation instead of reflux. Apparatus change कर लो, distillation plus heat instead of heat with reflux. अच्छा, reflux में क्या होता था? Reflux was the apparatus where nothing could come out, right? Anything that comes out, that thing, what would happen to that thing is it will condense and it will fall back into the container. Now what will happen is if you heat it and now you use distillation, so immediately what will happen, okay, the product is going to come out, it's going to evaporate, and you can collect it elsewhere. समझ आइए बात?
जी सर.
तो डिस्टिलेशन होता है अपनी और कलेक्ट. अच्छा, प्लस aldehydes have a lower boiling point compared to alcohols and carboxylic acid. So what you're going to collect is aldehydes. They are volatile. Alcohols and carboxylic acid are not that volatile because they can form hydrogen bonds. So they will evaporate with a lot more difficulty, but aldehydes, they don't have hydrogen bonds. ठीक है? तो aldehydes का boiling point भी relatively low है. So it's easier to evaporate them. तो आप क्या करोगे? हीट करोगे, reflux, but don't put a condenser on top. ठीक है? Take the vapor out and collect it somewhere else. So aldehydes have a lower boiling point. अच्छा, compared to alcohols and carboxylic acid, the other stuff that's mixed into it. So they will evaporate. You might be asked, okay, why does that work? They will immediately evaporate once they are formed. अच्छा, once they are formed. ठीक है, that's why you can stop at aldehydes. दूसरा भी कर लेते हैं quickly, इसको खत्म करते हैं कि there's another one which is the same, almost the same, secondary
सर
alcohol. हाँ जी.
सर प्राइमरी अल्कोहल्स एल्डिहाइड और एल्डिहाइड्स कार्बोक्सिलिक एसिड में सर अगर हम पहले दो मेथड इस्तेमाल करेंगे तो सर कलर चेंज तो सेम ही होगा ना,
हाँ,
यानी ऑरेंज टू ग्रीन,
अगर
तो हमें
रिफ्लक्स
कैसे पता चलेगा
अगर
कि एल्डिहाइड
रिफ्लक्स
में क्या?
नहीं, अगर तो रिफ्लक्स कर रहे हो फिर तो एंड में कार्बोक्सिलिक एसिड बनेगा ना,
जी सर।
या मिक्सर बन जाएगा एल्डिहाइड और कार्बोक्सिलिक एसिड का.
जी सर।
नहीं
ओके
कलर,
सर।
हाँ, वो तो अगर तुमने रुकना है ना एल्डिहाइड पे तो यू डोंट यूज रिफ्लक्स, यू यूज डिस्टिलेशन इंस्टेड ऑफ रिफ्लक्स.
ओके सर, ठीक है सर।
अच्छा, खैर अगला वाला सेकेंडरी अल्कोहल्स. ठीक है, सेकेंडरी अल्कोहल्स ये हटा दें. और अच्छा, so what's a secondary alcohol that's going to have two carbon chains. ठीक है, so there's going to be another carbon chain in a secondary alcohol. A secondary alcohol will turn into a ketone. Okay, it's got two carbon chains. उसके अंदर ये वाला पार्ट तो होगा ही नहीं. अच्छा, it's going to turn into a ketone. So not an aldehyde. ठीक है, इधर क्या बनेगा? It's going to form a ketone. और उससे आगे कुछ नहीं होगा. ठीक है, so ketones are going to get formed. बाकी conditions exactly same है. ठीक है, there's not going to be any further oxidation. Ketones are very resistant to oxidation. There's no further oxidation. And then you've got tertiary alcohols as well. They don't get oxidized. ठीक है, उनका चक्कर ही खत्म हो जाता है. So tertiary alcohols are not going to get oxidized. So tertiary alcohols are not so they're not oxidized at all. तो आपके पास फिर कौन से? You've got three. You've got primary alcohols. tertiary वाले जो होंगे वो नहीं ऑक्साइज होंगे. Secondary alcohols will get oxidized to ketones, while the primary ones will get oxidized to carboxylic acid, and if you can stop it at aldehydes as well. ठीक है, तो ये पूरा है. और इसका फिर कलम रिवर्स भी है, इसका उल्टा भी है, that's reduction. ठीक है, so this is oxidation of alcohols. इसके क्वेश्चंस पे कल ही करते हैं. All you have to do is you have to identify which one is a primary, which one is a secondary, which one is a tertiary alcohol. ठीक है, चलो ये क्लियर है.
ओके सर। जी सर।
चलो ठीक है, इसका फिर ना इसमें वो देख लेता हूँ. और कुछ नहीं है, बस कलर चेंजेस वगैरह याद नहीं है. एल्डिहाइड याद रखना कि एल्डिहाइड गेट्स ऑक्सीडाइज्ड by Tollens and Felling as well. ठीक है, वरना वो K2Cr2O7 और KMnO4 वही काम कर जाता है। चले ठीक है, ये फिर कल कंटिन्यू करते हैं, रिडक्शन कर लेंगे तो ये खत्म हो जाएगा, अल्कोहल्स खत्म हो जाएगा, तब फिर ज्यादातर खत्म हो जाएगा ऑर्गेनिक में, फिर कुछ ज्यादा रहेगा नहीं उसके बाद। ठीक है,
ओके सर।
चले, ओके,
अल्लाह।
अल्लाह हाफिज।
ओके, थैंक यू सर।